Okay, so we just want to graph not the function, just the vertical and horizontal asymptotes. Here's a horizontal asymptote, there's a vertical asymptote. Now, I'm going to encourage you again using the graphing calculator. I'll show you a neat little trick. We'll go to y equals. If you have an older one, you might not have this functionality, but F1 is green. So if I go alpha F1, what it'll allow me to do is have a template of a fraction, numerator, denominator. So I'm going to use that one. Notice I can put in the -5 and 4x minus 2. If I didn't have that, what I would have put in is I would have put in -5, it's a single thing, and then I would want to make sure when I graph the denominator, I do 4x subtract 2, and I put a parenthesis around it. If I don't put that parenthesis, it's not going to graph the same. I'm going to show you we'll have a blue and a red graph, and they will both be the same. So these are the way you have to do it. And then I'm going to go for a zoom standard. This is a -10, and notice they graph right on top of each other. I see a horizontal asymptote here at y equals 0, and I see a vertical asymptote somewhere here between 0 and 1, and we'll see how we have to calculate that. Okay. The reason, or one other way analytically to look at that for the horizontal, focus on the horizontal one, it's always a ratio of the top to the bottom. So if the degree of the variable is the same, so if we had an x on the top, so had this been like maybe -5x, 4x minus 2, you'd see that what this is going to behave like is a -5/4 would have been actually y equals -5/4 would be our horizontal asymptote. We don't have an x, so the degree of the top is smaller than the degree on the bottom. The degree on the bottom is, this is to the first power. This is literally x to the 0 power, so it's one less. Whenever that happens, the horizontal asymptote is always going to be y equals 0. And then the other option is if the top was bigger than the bottom, then there is no horizontal asymptote. So we either have one where basically x over x or x squared over x squared, that's going to be the ratio of those coefficients, or it's going to be 0. So we've got 0, so let's go ahead and put that in here. If I click on this, and it works a little different. Now I've got to put in a point. Well, it's where y equals 0. Actually, can I just, nope, I got to put something in there. I could make x anything, let's 5, but y is going to be 0. So that's a point on the horizontal line. See, it's there. Okay, it drew it. Vertical. The vertical asymptote is created whenever the denominator becomes 0, because that means it's going to shoot off to infinity. Whenever you divide by 0, it shoots off to infinity, because that's kind of what division by 0 is. So what makes 4x minus 2 equal 0? Well, we will add 2 to both sides. 4x equals 2. We'll divide by 4. And lo and behold, 2/4 or 1/2, that's a number between 0 and 1, as we can visually see here. That's where we want our vertical asymptote. So we come and say, give me a vertical asymptote, and it says, well, give me a point. Enter the x and y coordinates of a point on that asymptote. So we know the x is 1/2. Okay, 1/2. The y, not 1/20th, 1/2. The y can be any number because it's going to be a vertical line, right, going up and down. Let's just put 5. It doesn't really matter. You put anything. And there it is. It looks like we've got the two asymptotes, and we are in good shape. That's all there is to this one.